Okay. Well, um, you've got the proof homework due tonight and the program homework due Monday. So you've got the weekend to work on that. Today, we're going to be looking at some Turing machines. Now, the book has a definition for it. I'm not a big fan of it. Um, I'll show you why. So they say that there are an arbitrary number of tapes. I don't like that. Because the thing is, when Turing defined these machines in his paper, he calls them computing machines. He so he compares the computer to a person trying to compute something, which is a pretty smart thing to do, I guess. The machine is going to have it can be in a finite number of states, which he calls M configurations. So Q1, Q2, so on and so forth, Qn. That's pretty much the same here. That's what the state controls for. So it can be in any number of in any one of a finite number of states. They mention a start state, accept state, and reject state. He doesn't mention that. The machine is supplied with a tape, the analog of a paper running through it, and it divided into sections, each capable of bearing a symbol. At any moment, there's just one square being bearing the symbol, whatever that symbol is, which is in the machine. This is what is the machine is currently looking at. The symbol on the scanned square may be called the scanned symbol. Um, by and that's it, pretty much. Those are the base things. There's only one head, which is the big problem I have with this definition. So this textbook is making use of the fact that we've had um, almost 90 years of knowledge, increased knowledge after the fact, and they give away quite a number of things, at least two or three that I can think of, that are not obvious. And I kind of wish they would leave that to the reader to figure out. One of those things is, well, let's see if we can find out ourselves. So let's make some Turing machines to do, I believe palindromes, the first one. They do. All right. So our Turing machine looks kind of like this. Need my annotation tool. All right. So I've got some number of states. I've got a tape. And I have a head that the tape is divided into cells. so on and so forth. I think that should be enough. All right. So the name of the game here is going to be, when I read something from a cell, what should I do? So we've got some state. We'll say we start out there. We can call that one Q0. All right. What should I do to check if the symbols on this tape are a palindrome? So if I get something like ABBA, that it should tell me that it is. And we can assume that the head starts out over here on the left. We'll assume it starts there. Okay, what should I do? Move to a new state on A. Okay. Why would I want to do that? What would that state represent? So Q0 is just our initial state. The only thing it currently represents is that it's an initial state. I can make a new one. This is neither. This is a Turing machine. Store it in the cell. What do you mean by store it in the cell? I could make a new state. I can call it Q1. Okay, I can do that. What should I do with this Q1? What does it represent? So maybe to help you guys out, I will put an example in the tape. All right, that is an example of a tape that would be fed to a machine that is supposed to determine whether or not the input is a palindrome. So what should I do? And you don't have to be answering in terms of moving the head and storing stuff. You could just tell me what's the thought process of how do I determine something's a Turing or palindrome. The important parts of how we start out is that we are in this initial state. It's currently the only thing this state means is that it's the initial state. And the head of our, the head is reading the first cell in the tape. Tape goes on forever. The input's stored in the tape. Can nobody describe the process to me that they would use to determine whether something's a palindrome? We've only done it 50 million times.
Wait, you want it with using just how we think when it's written, or like with the machine or something?
Eventually, we're going to get to how the machine's going to do it. But how the machine does it's not that different from how you would do it. The only rules are you can only look at, you've only got one, imagine the tape's some big, long tape. You can only look at one section at a time. You can only read and you can only write at one section at a time. That's your only restriction. So what would you do?
At least if it's an even palindrome, I will cut it in
How do you know if
half.
it's an even palindrome?
I just know.
Just know. That's incredible. Just you have a superpower to know if something's an even palindrome or not.
Yeah.
Use a PDA. Well, no, we're not going to use a PDA. We're going to use a Turing machine. So how I would say, what would a Turing machine look like that determined whether the input was of even length or odd length? Well, here's how I would do something like that. Until we get to the first blank symbol, we're going to start out in our initial state, which will indicate that we're currently looking at something that's even. And if I read any symbol whatsoever, I'm going to go to this state over here that says it's odd. Okay, and then I'm going to move the tape one to the right. No, I want to draw. I'm going to move the tape one to the right, and I'm going to go to the odd state. So this is the even state. And this is the odd state. Now this Turing machine accepts a string if it is of even length, and it rejects anything else. Okay. So if I read any symbol, I'm going to use X to well, I'll just write the whole thing out. Read any non-blank symbol. I wonder if I can make this smaller. I don't think I can. It's not like this is the best tool for this. Read any non-blank symbol. Move the head one space right, and don't write anything. All right. All right. It's hard to read, but that's what we got to deal with right now. Okay, so I've gone into a state where I know my string is currently odd. Now, if I see another symbol that's not blank, I'm going to go back over here. Same as above, but go to even state. All right, and I'm going to move the head to the right, and I'm going to keep trucking along. Now I've got a process here for what I need to do if that's the case. Now, if I run across a blank symbol, meaning I've reached the end of the input, well, if I'm over here, I want to accept the state, and if I'm over here, or accept the string, and if I'm over here, I want to reject it. So I'm going to have a accept state, and we can have a reject state here. That's fine too. We'll come up with whatever syntax we want these to look like later. On blank, reject. On blank, accept. So how does this Turing machine work? Well, we start here. If I read anything that's not a blank symbol, I'm going to move here. I'm going to move the tape one to the right. I'm not going to write anything. If I read another symbol that's not blank, I'm going to move to Q0 and move the tape or move the head one to the right. And I'm not going to write anything. And I'm going to keep doing that until I read a blank symbol. If I read a blank symbol while I'm in this odd state, I'm not going to accept the string. I'm going to reject it. If I'm over here and I read a blank symbol, I'm going to accept the string because I've gone through the entire string, started here, move the tape one to the right, keep going, keep going, keep going. I've gone from even, odd, even, odd, even, odd, even, odd, and I've reached a blank symbol, meaning I'm done reading the string. I'm going to go to this state that says the string's done, it's of even length, and I accept it. So that's how a Turing machine works. Really, if you can describe the process of what you want to do in terms of looking at one thing at a time and what state in your mind you are keeping track of things, that's all you have to do. So let's try doing that for the original question, which is a palindrome. So what is the process for determining whether something's a palindrome when you can only look at one thing at a time? Now you could consider its length. You can consider the symbol you're looking at. You can move along using a stack. I'm less concerned about the implementation. I'm more concerned about what the process is. So I feel like you're all overcomplicating this. I'm just asking. I'm giving you a tape, one symbol at a time, and I'm wanting you to be able to tell me if it's a palindrome or not. What's your thought process on what you would do? I'm actually handing you a big long piece of paper. The only rule is you can only look at one thing at a time. I can't figure out how to do it while looking at one thing at a time. Okay, well, looking at one thing at a time, well, why do you want to use a stack so much? Stacks aren't that great. Trying to think about how to find the middle. Now that is the first time somebody said something that we can work with. Trying to find the middle, that's something you can absolutely do. But yes, with a stack you can push and pop. That is something you can do. Also with a queue you can push and pop, and with a list you can add and do a whole bunch of stuff. That's implementation details. We don't particularly care about that right now. But what Monica said is really the important thing here, because that's how you keep track. Well, here's the thing. Now you've got memory. See this tape here? I can write whatever I want, wherever I want. I can move this head, I can read, and I can write. Those are the steps I can take. So if I want to, let's say, find the the length of this tape. There's a really silly way I can do it. So there's symbols on this tape, and it's 4. Well, here's what I can do. I can read that this is a non-blank symbol. All right. So now I'm going to describe a process. Move to the end of the string until I've found the first blank, and then move 1 to the right, and write an X here. And then move back to the next cell. So I'm gonna read an A, be like, all right, length 1. Go to the end of the string, go 1 to the right, put an X. Now go back to the next character, to a B. I'm gonna do this whole process, and now I'm gonna have 4 X's on the tape here. Those 4 X's describe the length of the tape. Did that do us much good? Maybe, because it's really not that different from just being a bunch of symbols here. I just replaced them with X's. But there are 4 X's and the length is 4. You don't have to, you can move any way you want. You can move, you can essentially move as many steps as you want, but really you can only move 1 at a time. But if I want to move 5, just move 1 time, move once 5 times. Do we automatically know the length of the tape? The tape is infinite. Well, it's functionally infinite. What is on the tape? On the tape, the beginning cells is the input for as long as the input is, and then after that, it's blank. In fact, I'll even say that this character here is, I don't have the box symbol. That's the one I would use. I'll use this to represent the box symbol. It is a special symbol indicating the end of the string. Everything else is blank. What do I mean by functionally infinite? No computer can store an infinite amount of space. Envision a computer where its memory is as much as you want, but it's not infinite. So you fill up the memory, and then you're like, haha, I filled it all up. But then you look down, and there's another stick of RAM. You're like, well, that's weird. Fill that up too. So you fill it up, and you're like, I did it, and there's another stick of RAM. That's functionally infinite. Look at the first element and look at the, hey, someone either read the book or is very clever. That is the exact process that you want to do. Look at the first element and look at the last element and compare. If they're the same, cool, move inward. Do the same until we either reach the middle or we, it's even or odd. That is exactly what I was looking for, because you didn't even tell me which states to move to or where to move the head. That is just the process you would use of, okay, here's an A, here's another A. All right, the outside matches. Let's move inward. All right, now what's this symbol? Okay, let's move to the right. Okay, that's the same thing. Same process. We're going to keep doing it. That's actually exactly how they do it in the book. So, how would we want to do that? Well, we got a couple things. Okay, we can look at multiple points on a tape at a time. No. That is a very good question. Remind me to visit that once we're done. All right, so what I want you to do now is describe to me the states we're going to need. And those states are representative of what are the current things my brain's keeping track of. Now, they're all listed out on the screen here, which is fine. You can use those to kind of get your noggin jogging. But I don't want you to just read them off to me. I want you to describe what we are trying to do. So obviously, we've got an initial state. In fact, I'm just going to scroll up so you can't see them. It makes things easier. Got an initial state. Q0 is initial. There's nothing much more to say there. Now, you say, look at the first character and compare it to the last character. Okay. If our alphabet is A's and B's, what are the possible worlds that I could see a character here? What are the characters I could see there? That the you could say start of the string, but I want you to think more in every time we do this process, we're going to move the start of the string. So what character, we need a state for seeing an A on the left and a state for seeing a B on the left. Yeah, pretty much. Q1 on something, back to Q if the next is the same. Yeah, that's kind of what we're doing. So I'm gonna say, let's call a state. I see an A as the beginning of my string. I'm gonna call it the leftmost side because we're gonna be moving what the leftmost side is as we go along. So I see an A. Now, what does this mean? It means begin the process of moving to the other side of the tape and look for an A. I'm going to call this state QA. There's an A on the left-hand side of the tape. Move to right-hand side of the tape to find an A. That is what this state represents. So what a state represents is obviously the state of the program. The initial state is, there's not much more to say. We haven't done anything yet. We're just in the initial state. You may even call this some weird standby. We're not doing anything. What is the QA state? The QA state is, I found an A on the left-hand side. I need to find an A on the right-hand side. So do whatever I need to do to get over there. All right. So once I get to the, I'm going to move all the way. Okay, so let me ask you this. The only instructions you're allowed to do right now are read, write. You're not going to want to use write. Move left and move right. How can you, okay, so find the first blank. Very good. How do I describe that in terms of move left one space and read, or move right one space if you want, and read the current symbol? I can only do one thing at a time. Move left, read, blank else, repeat. Yep, that's exactly right. So what we want to do is we want to move the head to the right, read the symbol. If it's blank, stop. Actually, I think we kind of want to move left one. Otherwise, keep going. So we've got this state, QA. We're going to have another one, QB. And so since people are playing along better, oops. Well, those are backwards. Well, I guess I can undo it. QA and QB. All right. Now, since people are playing along better, I'll let people look more at this. So the process we want to do, my brain just died. So QB, we found a B on the left-hand side. Move to the right-hand side to find a B. Now, process for move. Well, move to find. We'll call it that. What are the rules for what we do here? Well, it's pretty simple. Read the symbol. If blank, then let's say go left. Otherwise, go right and repeat. That is what we're going to call our process for moving to for finding the end and getting there. Okay. So what we have currently is whatever beginning state we're in. I found an A on the left-hand side, and I found a B on the left-hand side. While we're in these states here, my current task is to move to the right-hand side. What's the next thing I should, are we going to need more states? Yes, we are, but what would those states look like? States to compare with ones we already have. I think what you're trying to say is we've reached the end of the tape and we've moved back left one. Test it to see if it was what was on the left-hand side. Is that what you're trying to say? Okay, now let me ask you this. Is that, you do need an accept state. You do not need a reject state. That's one of the things I don't like about their definition. In Turing's paper, there's no such thing. But it's absolutely fine to use a reject state. I just don't want you to get it in your head that a Turing machine must have one. But it's often useful. So yeah, we've got an accept. While I'm drawing this, I want you all to think about, so Juanita said, well, I'm going to paraphrase. She's saying, we've done the process of moving to the end of the string. We've reached the empty symbol. And we want to compare the symbol. Well, I'm gonna. So many good questions. We want to compare the symbol on the right-hand side that we're interested in to the one that we saw on the left. So what do we do? How do we do that? And the process of move to compare is go read the symbol on the tape. If it is blank, then stop. Otherwise, move right and repeat. You might all notice that I changed that a little bit because I thought of something that might be interesting. Okay, so I will draw an accept state and I will draw a reject state. So here we'll put the accept state and here I'll put the reject state. Actually, no, I'll put it down here. And I can't change the font size. Yes, exactly. This sneak preview has more power. You can do, I don't want to give everything away. You can do more with this than you can with a context-free grammar or a push-down automata or a finite state automata. So we'll call this accept. I can't make the font better, sorry. I can make the, change the color. Ooh, I can. Look at that. All right. Reject. Cool. Okay. So I've got a state saying, starting out, I've got a state saying, I've read a symbol on the left. Start moving to the right and find the symbol on the right. I've got that for each symbol in the alphabet. So I'm going to need something saying I've moved all the way to the right and I found the blank. What should I do? So I've moved the tape. I'm sorry, I've moved the head. Draw arrow all the way here. I don't like how that looks. I'm going to change that. I've moved the head all the way here. Boop. What do I do now? There was an A on the left. How do I know that? Because I'm in the QA state. I'm not in the QB state. Move head left 1 and read the symbol to compare. Okay, I can do that. Move the head left. All right. The head is moved left. If I read the symbol, it will be A. I'm in the QA state, so it makes sense to say if I read an A, actually, no, I'm not. I'm not. I technically am in the QA state, but I don't think we should be. We've finished our process of moving to the end. So I think we need a new state saying, I've moved to the end and now I want to compare. So let's call that, I mean, they call it QA prime, that's fine. Text. Q prime A. That's what they call it. That's fine. Now in this state, I want to read the symbol that is matching to the one that was on the left-hand side. We'll call that the right-hand symbol. Read the right-hand symbol and test it. And since I'm in the Q prime A state, it better be an A. If it's not, well, I can just move to the reject. If it is an A, we can do some other stuff. All right. Is that good? Should I do more? Should I read? Should I write? What should I do? Now, what I'm going to do, and I'm going to think about this for how you guys have to draw and read stuff. Interesting. Right blank on the last A. Very interesting. You want to delete the symbol. We can do that. We can do that. All right. I'm just trying to think of the best way to. Here, I'll show an example of what I'm trying to think. So I'm going to call this process, it's obviously called move to compare, but I'm just going to call it move because that's smaller. All right. So in order to get from state QA to QB, what's the action we should be QA to Q prime A? What's the action we should be taking? Well, it's move. I've described the process over here because there's no push pop whatever. There's a lot of things you can do, and I'm describing the process here. And similarly, I'm going to do the same thing for Q prime B. So now while I'm doing that, you guys are all thinking of the very next step. I need you to describe the process like I have for move for what we're going to do to move back. So far I've heard go left 1, read the symbol if it matches the one we're in the state, replace it with blank, and then something. So figure out what the something 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 is while I do this. Huh, I can make those smaller, can't I? Cool. Hey, that looks pretty good. Erase. No. Oh man, that's what I get for making the boxes so big. QA. I'm gonna do that. That's better. Arrow. Come on. Then text. We're gonna call that move. And then I want another one. Text. Call that move. Shrink the box so I don't have terrible problems. Call this Q prime B. Well, that okay, whatever. All right. All right. I'll give you guys a freebie in that I will describe the process of reject. A non-matching symbol was read to the left of the first blank. Go to the reject state and don't do anything else ever. Do not halt. I have intentionally not looked at this chat because I want you to think without me interfering, but I'm about to be back. Okay. I'll even put that there. All right. So what about the left math? Okay, where did I miss? We would have to delete it, but first find it. What? That's what we're comparing our action. Move head left read symbol if it matches, stop. Oh, I see. If you're at the start, then stop, else move. You like the big text? I can't fit all that. I'll make it one bigger, but I'm not going to go back and change everything because that would take forever. Okay. So we need to describe this process here. I'll call it move back. Move back. Man, maybe that. Okay, I'll try to use the bigger font on the right, but I got to use a smaller font over here. Otherwise it won't fit. All right, move back. All right, what does the move back process look like? Well, I reached a blank and a matching symbol was found. Actually, this isn't reached the first blank and a matching symbol was found directly to the left. Now what? So I reached a blank and I moved left and I read a matching symbol. What should I do? Go back to Q0. I was just thinking the same thing. Let's see if I can erase this without messing everything up. No. Everything's terrible. Yep, this isn't going to be pretty. Sorry. Okay, so yeah, I think we do want to go back to Q0. All right. Because if we go to QA, that means no matter if I found a B or an A, I'm in the QA state, meaning go to the right and look for an A. Find find left A, delete it, move to rightmost symbol. Otherwise, go back to the beginning where the A was deleted and repeat the new process. Okay, so Summer, I'm going to say what I think you're trying to say. I can't tell if you're starting from the beginning or starting from Q prime A. So I'll start from the beginning. Read a symbol, begin the process of moving to the right. Find the first blank. Go left one. If it's a matching symbol, replace that symbol with a blank. Go all the way to the left. Replace that symbol. Either find a blank or find the beginning of the tape. Replace that symbol with a blank. Move to the right and repeat the process. Move to the right one and repeat the process. Is that what you're trying to say? You think so? Okay. Maybe say what you were trying to say bit by bit to see if I can follow. Does anybody else have any ideas? Because move back is not finished. The only thing I've said is we've reached the first blank. We found a matching symbol and we moved directly to the left. That makes sense because when we can, then we can be removing the matching pairs from the answer. That is the idea. That is the idea of we're going to find matching symbols on the outside, replace them with blanks, and move inward. If we find the matching symbol, should we not delete it? Yes, we should. So that probably needs to go over here. Replace matching symbol. Well, I'll just say the things you can do, you can read, you can write, you can move. So write blank. And then what? We want to move left until what? Move back needs to move to the left until we reach the start of the tape. Very good. Perfect. Until we read a blank or start of tape. As far as I'm concerned, that's perfect. So we've reached the first blank symbol and a matching symbol is found directly to the left. Right, blank, and then move left until we reach a blank or the start of the tape. There's one more thing I'll put here. If well, I think we can handle that in Q0, so that's fine. Basically, I was trying to say if you're done, I think we can handle it in Q0. Okay, we're back to Q0. I'll describe a process here. We're going to call it, I can't make this much prettier, sorry guys. We'll call it read. Read. I should just be using OneNote instead, but I was trying to keep the stuff on the page for the recording while I do it. There's no good way to do it. All right, so the read process, we've already done part of it. If blank, move, or what are you trying to describe, Brandon? What process are you trying to describe? All right, so the read process. Read the symbol, move to QA or QB. I'll say move to respective state. And begin move. Well, I guess I don't need to say that. That's on the diagram. Okay. Reading left until blank or start of the tape, then if blank, move the head right one. Oh, I see. You're saying, all right. Yeah. So I will actually put that here. Then move right one, because it makes more sense too. Because that puts our read, the position of our head where we want it, instead of having to do it in the middle of the read step. All right, so here's what we've done. We've replaced this with this needs to say if we reach a blank, move right one. If it's the start of the tape, then don't. But I'm not going to write that. So we've replaced that A with blank. And I'm going to go until this example's finished. Obviously, it's 8:50. I have a good Simpsons joke for that, but I'm not sure everyone would get it. So we've replaced the symbol, and we've moved the tape back here because I reached the start of the tape. And since I reached the start of the tape, I don't have to move right yet. Okay, if I had reached a blank, then I would have had to move right one. All right, so I'm here. What should I do? Am I good to read again? Nope. No, I'm not. So there's something more in the move back that we need to describe. What would that be? Delete all matching symbols. What's a matching symbol? All I know is I'm reading some symbol. All I know is for some reason I've moved back and there's an A here. Won't it have been more efficient to have deleted it from the beginning? Sure, we could do that. If you want to say here, but first delete the symbol. We can do that. Once you go back, delete the first element, move right one. That's fine too. Either one. We'll go with Summer's idea because that's what came up first. So now we have the case where we're never going to reach the beginning of the tape, I think. Because we, I'll explain shortly. When your head is here to compare with that A, you've got no idea what's over here because the head's here. You don't know what's here. But you are in the QA state. The QA state says, hey, there was an A over there. Had there been a B over there, we'd be in the QB state. Or I guess we may be in the Q prime A state. I'm not sure which. Point is, the state you're in tells you which symbol you saw back there. You're using two different states so that you can know, hey, I need to look for an A or I need to look for a B. That's how. You sound like you're not convinced. So we start out, I read an A. So I'm going to move to the I found an A state. And I'm going to begin the move process of going to the end of the tape, go left one, and look for an A. Why would I look for an A instead of a B? Because I'm in the QA state. And so I find a QA. I find an A. I'm like, cool. All right, delete it and go back to the start. Now I'm back here. And now I see my head is right here. So I'm going to do the read operation. And the read operation here says read a symbol, move to the respective QA or QB state. So which state should I go to, QA or QB? Okay, I go to QB. All right, so now I'm here. And my process is move to the end of the tape. So go to the right until I find a blank and then go left one. But first, delete the symbol. That's what it says, so that's what I'm going to do. Now, before I move on, should I be looking for an A or a B at the end of this tape here, and why? Why do I know which one I'm looking for? I think if I do, yep, that's exactly what I thought was going to happen. Because I didn't shrink the thing. So am I looking for an A or a B? So I move to the end, go left one, and I'm going to look for a symbol. I'm going to look for a B because I'm in the QB state. I'm in this state right here. Well, I guess technically I'm here, but this is where I'm going. Does that make sense? I'm looking for a B because I'm in this state. I'm not looking for a B because I had a B over here. I'm looking for a B because I'm in this state. And I'm in this state because there was a B over there. So the head's here. All right. I found a B. What does our move back symbol or operation say? It reached the first blank, or the first blank was here. And I went left. And a matching symbol is found. So I'm going to write a blank there. I don't even know what I'm doing. I'm just reading what the process says because that's what machines do. They don't know anything. They just do what you tell them to very quickly. All right, I'm going to write that and then move left until blank or start the tape and then move right one. All right. Well, there's a lot of ways to handle what's about to happen, but now we're here. And it said move right one, so now we're back here. We're literally back where we were, but now we're in Q0. What should I do? Move to accept. Why? We only have blanks. Well, I don't know anything about that. All I know is the current symbol I'm looking at is blank. The machine can only look at one symbol at a time. It doesn't know what's on the left. It doesn't know what's on the right unless I move. So all I know is the current symbol on the tape is blank or empty, whichever you want to say. It's difficult for me to give a hint here without giving it away. There is an edit to one of these 4 processes here that I need to make. And let's go through them. Should I change move to handle that we're essentially done? Should I change this one? Okay. What about reject? Should I change reject? Trying to get you to tell me how I know I can move to the accept state. Let me ask this. From which state do I move to the accept state? Q0, very good. So if I'm in Q0, what is the only condition on which I can move to the accept state? What is the symbol I should be reading if the tape is full of blanks? I don't know if the tape's full of blanks. I can't know that. Well, I could describe a process of check the entire tape for blanks. I could do that, but I don't think we need to. If you read a blank, that is correct. If I am, that's going to be a big arrow again. It's fine. I don't care. If you're in Q0 and you read a blank, there's only two things that could happen. One, you started out with a blank string and an empty string is a palindrome. Two, you've done a bunch of processes to move matching symbols off of the edges and get to the middle. And therefore, if you've gotten to a blank and you haven't ended up in the reject state, you've got a palindrome. So there is one more thing we need to handle, and that is the idea of an odd palindrome. So if someone could tell me what to change to fix that, and then this will be good. A Turing machine halts. It is said to halt when it accepts the input. Okay, so there's only one more thing we got to do because this won't handle an odd palindrome very well. Now, I'll give you a hint. I think we should change the process in move. You could do it in read also if you want, but either way, you're going to be doing the same thing. Let's say I have an odd palindrome. I'll give you the easiest one I can think of. Now, since we've done an even palindrome, I'm going to erase this stuff because I don't need it anymore. All right. I'm going to give you an odd palindrome. There you go. And all right, this is the input for an odd palindrome, or this is an input for an odd palindrome. Okay, so let's do the process. All right, I read an A. I'm in Q0. All right, I read an A. Begin the process of move. Okay, I move all the way to the right. I go one to the left, and I found an A. I read an A. I replace it with a blank. Actually, I think we don't need to change anything. So, la-di-da-di-da. I didn't think that would happen, but that's cool. What I was going to say is if the symbol immediately to the right was a blank, then you're done. But turns out the thing works anyways. So, hooray. So you have here a Turing machine for checking if something's a palindrome or not. Very cool. We've got what, 1, 2, 3, 4 processes. Really, you only need 3 because as long as the machine doesn't halt and you run out of input, then you're rejecting. So yeah, that is that. Anybody got questions? Let's see what these guys said. So this is all this stuff we described here is giving the transition function. Thing is, the reason I didn't say transition function is because that's not the way he defines them. He gives, here's the configuration we're in. I'm in whatever state, and here's the symbol I'm reading. And here's the operation I want to do. That's why I described it this way rather than giving a transition function. I would rather describe it from the ground up and have people uncover the cool parts than just give all the cool parts. That's the best way I can describe it. Okie doke. So, questions on that? You kind of missed how it accepts odd. Well, it happened by accident. It read, so if you have an odd palindrome, eventually you're going to end up with one character left in the string, right? Even if it had more to start with, you're going to end up with one left. Well, I read that character. I move to the first blank symbol on the right. So I move directly to the right. But before I did that, I deleted the symbol. So what I'm going to do is move to the left, read blank, and be done. The Wednesday lecture is in the homework assignment thingy. The link is, at least. So the homework, I'm not going to give you triple homework because that would be lame. Tonight is the Theorem 3 proof. And then over the weekend, I want you to look at that Python program and tell me what's wrong with it. What is it? I'm going to erase all the stuff. This program here, it is provably undoable, yet I've written something that appears to have done what I said can't be done. So I must be doing something incorrectly here. I must be saying I'm doing the undoable task, but then not actually doing it somewhere. So I'm missing something. So you got the code. I've given you the code. I need you to go through it and tell me which part seems like it could be not correct. So that's that.